Do you hear me? Yes? No? Yeah? I think now it's working. Okay, my talk is in fact linked to the previous one because but they talked about lots of things, but it's linked in the thing of the middle, the performance monitoring. Okay, I'm going to talk a little bit about a patch we have in Tryton D for monitoring some things. Some of them overlap with what Copengo did. And I think it's, again, an occasion to talk about what kind of tools we could provide in Tryton Core or make it easy to create this kind of tools. Okay. The first point is why, or what, sorry, it's very slow. Okay. Why have application performance monitoring? The word already says it. It's for performance, so it's not usually linked to bugs and crashes, although we have in this small patch, which is of course available in Bitbucket, we have some tools that help a little bit managing better reporting of bugs. But that's not the key point. The key point, of course, is performance. And we've got some different requirements from Copengo. Copengo said they cannot access the Tryton D server directly. In our case, we always have access to Tryton D server of our customers. But the problem sometimes in analyzing the performance issues is that they have already happened. So we also would like to cover moments in which the performance is bad, but you cannot easily reproduce that situation. Okay, so that would be an added requirement to what Copengo's needs. Okay, and the term application performance monitoring, you will see in many places that we talk not only about the application itself, but the full stack. Okay, we've suffered problems. Not a lot with hardware, but of course there are sometimes problems with hardware. We've suffered problems with virtualization. The customer says, no, the virtualization technology is great. It's being used by NASA, I don't know, and it cannot fail. And you constantly cannot reproduce the problem. You say, oh, it works more or less okay. The customer said that it's very slow, and until you test it in the production server, you don't have real feedback of what slow means for them. So there's another point here. Of course, PostgreSQL, we have suffered problems with older versions of PostgreSQL, 9.1, for example, or 9.2, I think, with some large IDs in a select query. Could be really slow in some situations. Of course, there is Python. You can use Python or PyPy or PyP or whatever it's named. Sorry, I will. Put the cable. Of course, then there is Tryton D. Oh, don't worry. Thank you. Most of the time, it's not Tryton D, but there are sometimes things to improve in Tryton D. Most usually, it's Tryton D modules, something that you have developed for the customer, which is not perfectly optimized. It could be the network. Every now and then, we get requests from customers that they have some problems, and it might be specific to them. And of course, there's the client. We have several known performance issues with Tryton client, especially in tree lists and things like that. So ideally, we would like to see a picture of everything, okay? But I'm going to concentrate only on, I think this is, well, I'm going to concentrate only on the application part, okay? So apm.py is a file which also needs a small patch to dispatcher.py, which adds basically three kind of improvements. One of them is a couple of signals. You can seek user one to the Tryton D server, and it will print the RPC calls that are being executed by the server at that moment. Okay, I can show you. I think I've got. I tried it. You can. Do you see it from the? Okay, this is a standard Tryton log. Okay, but here it's the output of sending the signal user one to Tryton D with dispatch. Okay, it will show you a transaction ID that we create randomly, the database name, the database PID, because this would allow you to link, to have this complete vision of the performance issues. If you can see that the CPU of PostgreSQL is high on one process ID, you can know which of your RPC requests is using that process ID, okay? That database, that PostgreSQL process ID. You've got the user, you've got the host, timestamp when it started, and the total elapsed time in seconds for the request. And of course, some information about the object and the RPC call and some part of the parameters given to it, okay? Then you've got also the possibility of sending signal user one, signal user two, that's just using kill, you know, the Unix command line kill signal user two to the process ID. And it will print you a backtrace of what Tryton is doing at that moment. Okay, I think there's a large log here, but I can. I'm going to start the server, and even if I don't. Okay, this is a small script that we have to easily find the process ID and send the signal to all process IDs if you are using several Tryton processes. Okay, this is the top operation, which is if I had some RPC calls here, it would be showing what is going on. Okay, so I would have to probably duplicate here, and you would have to search on the log. Because the operation is very slow, you need to, sorry, it's very fast. Okay, here you have the top operation, and which is signal user one. And then you can have a backtrace of what Tryton D is doing at that moment. And this is very useful because even in debugging when developing, because you will find very easily which part of Tryton is your bottleneck, or maybe you have a loop that it's constantly doing the same thing several times. So it's a very simple way of watching or seeing what is going on. And it's also, of course, useful for a production server. Okay? So these are the two signals that the patch provides. Then this overlaps with Copengo's features. We also have profiling the possibility of profiling. What we do here is that we can use either cProfile or the profiler of Python or VMProf. VMProf is a PyPy project which is a different profiler. cProfile or profile from Python, it's exhaustive. It tells you exactly the time spent on each and every call, but this adds a lot of overhead. It's not something that you can put continuously in a production server. On the other side, VMProf, it's a profiler that basically it's kind of the backtrace thing that I have just shown, and it will check for backtraces every 10 milliseconds, every 15 milliseconds, or the amount of time you put on it, and it will create a profile out of this information. It adds around 2 or 3% overhead only in Python, so it can be used in a production system. And what we do here is that well, I just wanted to show you also, and it has VMProf. You have a tool to view it in a nice picture, but of course you can use it in the console with a similar output of the one they showed for profile. Okay. So again, we configure it in tryton.conf, and you can say, okay, start this profiler under these conditions. And the conditions can include the RPC call, but it can include the user, for example, or even the parameters. You can use a small simple eval expression to say I want or I don't want to start the profiler and which profiler you want. And then we store this backtrace according to a criteria. So you might say, okay, I want to VMProf all requests of this RPC call, but in fact, I just want to store the backtrace of RPC calls that take more than 2 seconds, for example. So you just don't have the need of a lot of data. And it stores the transaction ID. So as we will see afterwards, we can add some logging information, and you can link all the information from what I already talked here. Okay, you will have the process ID, and you can link it to the backtrace. The process ID of the PostgreSQL server, and link it to the backtrace. Sorry, link it to the profile. And apart from the profiling, we also have some logging. We just create a log file, very simple one, in JSON format, so it's easier to parse if needed, in which we put the transaction ID, the time spent, the RPC request, user, etc. And it's again based on our criteria in Tryton D. Instead of storing all your RPC calls, if you don't want, you can just store all those RPC calls that take more than a given time, and that's it. Okay. And eventually, the patch also has something similar to Sentry patch that Open Labs guys created, which instead of showing you a backtrace when the application crashes, it says, okay, we are going to fix this, and it gives the user a transaction ID, so the user can call you and say, I've got a problem, and the number is 21 or whatever. Okay? And we could even make it more user-friendly because it's going to be a transaction ID, a long number, so we could maybe make an improvement and give a string that the user can understand and memorize. So that's basically it. I don't know if there are any questions. We also have a small application for gathering data, which is not published yet, in which we store and send information in JSON format, in which we pick information from the server for monitoring the server. And our idea, but it's not done yet, is to probably pick up some information from the logs and the APM patch I just mentioned. Okay. So, are there any questions? No? Anyone for the breakfast? Yeah.
Okay.
So that's it.
So thank you, Albert.